8:38. Okay, so today we're going to look at another type of quadratic story problems, right? We already looked at problems that dealt with area, right? And we talked about the idea that if we had a square, right, and we knew what the length was compared to the width, that we could then write an equation and we could solve it. Okay, that's not the type of story problem we're looking at today. Today we're looking at a story problem where something is represented with a curve. So now that we know that quadratics make a parabola, what does a parabola look like? Right, this arch shape. Now that we know that that's what it makes, it should then make sense. Okay, so I'm going to make my little coordinate plane here. Okay, and I'm going to make a person. Very detailed, right? And let's say this person kicks a football. So here's my football. Oh, that was really bad football. What happens when this football gets kicked? It goes in the air, and then it goes back down. Right? So it goes up and then down. Doesn't that look a whole lot like a parabola? Oh, because it is. Okay. So we can then talk about any type of those motions. Okay, we call it vertical motion, right? It's going up, and then it comes back down. Okay, we can talk about any of that vertical motion with a quadratic. So roller coaster curves, throwing a ball. Okay, all of that has that same sort of motion happening. Guys, we're taking notes. Headsets up. No headphones. Okay. So if we look at number 1, it says, suppose a football player kicks a ball and gives it an initial upward velocity of 47 feet per second. Now, when I watch students read these types of problems, they read that first sentence and they go, yep, no, I don't know anything about initial upward velocity, so I can't do this problem. Next. And they just skip it. Okay, the key to these problems is to read the entire thing. Okay, read it. Make sure that you are actually making sure you do or you don't know something before you've convinced yourself you can't do it. Because it then tells us the starting height of the football is 3 feet. We represent this with. And what does it give us? A quadratic equation. Do we know how to do things with quadratic equations? Yes. Okay, so it then says, if no one catches the ball, when will it hit the ground? Okay, so let's look over here at our picture again. Where in this picture is this ball hitting the ground? Right over here? Okay, so can we agree that over here would be an x-intercept? How did we decide last unit that we could find an x-intercept?
Use points out form.
Do what?
Use points out form.
No, because this is a quadratic, so we can't use point slope. What is an x-intercept also called? Okay, it could be the root. It could be the 0. What else? There's one more. X-intercept.
No. Just give us the first letter.
What is it? Solution.
I've never heard of one. Good job. Yeah, I'll never heard of that.
Yeah, we've definitely said that multiple times. Okay? Guys, all this is asking us to do is to find this point, which is a solution for this quadratic. Do we know how to solve a quadratic?
Yes.
What are ways that we can solve quadratics? With the quadratic formula. With factoring, with completing the square, with any of those options. Now, I think for this problem, I think we're going to want to choose the quadratic formula. Okay, so the quadratic formula returns, which says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what does a equal in this quadratic? Negative 16. What does b equal? 47. What does c equal? 3. So we start plugging in. Right? Plug and chug. So negative 47 plus or minus 47 squared. If you're like, Mrs. McKinney, I have no idea what you're doing, you should go back and watch our videos over the quadratic formula because we did that a bajillion times. Right? All over 2 times negative 16. It's fair. Okay. Okay, once we get to this point, what do we then do next?
Solve in this.
Right, we calculate inside the square root, right? So we can just pick up a calculator. And we'll get negative 47 plus or minus the square root of 2401 all over negative 32. Then what do we do? So we'll get negative 47 plus or minus 49 all over negative 32. Then what will we do? 2 options. Negative 47 plus 49 over negative 32. And negative 47 minus 49 over negative 32. Then what do we do? Calculate both of those options, right? So we get negative 0.0625. Whoops. And 3. So is our answer negative 0.0625 and 3? Why not?
It can't be a negative.
Okay, so what are we talking about? What are we trying to find an answer of?
When will it hit the ground?
And what does when mean?
Time.
Time. Can time be negative?
No.
No, right? So this is not a reasonable domain because time can't be negative. So what is our answer going to be? 3 seconds. Because we're talking about time and we see the label of seconds up here. So our answer will be that the ball hits the ground after 3 seconds. Okay, that makes sense, right? If it's a kid, kick a ball, it's 3 seconds. We're not talking about professional football here.
Oh, it's a kid.
Well, whatever.
Or the ball. The ball will hit the ground in 3 seconds.
Yep, the ball will hit the ground in 3 seconds. Do we see how that didn't require us to actually understand much of what we read?
No. Wait, that's
right? The equation was given to us, so who cares if we know about initial upward velocity? Now, what is initial upward velocity? Does anyone know? What is velocity?
Fast.
Speed over time.
Speed and distance.
Well, right, it's the force that we're putting on the ball as it goes upward, right? I don't need like a fancy label, right? But it's that initial force that the ball is getting as it's going upward. Okay, the more force, the harder you're hitting it, right? More velocity it's going to have. Does that make sense? Also, not because it's super important, but this -16 didn't just magically appear. Picked something, it would just keep going up, right? Gravity is what makes it come back down.
Why isn't math and science one class? Because like, remember how like social studies and like math, like English?
So this is why. Math and science are one class when you take physics. Okay? Right now, you don't know enough math to apply it fully to the science. So we learn this type of math so that when you get to physics, you can do more with it. Right? So that's the idea I keep saying of we're still at that basic level, but the math on its own that we're learning is not important. It's when you apply it, when you get to physics, that you're like, ooh, cool. Right? Or reverse, when you get to calculus, you can do things like, what's the least amount of material you can use to, do you guys remember, you guys might be too young, but do you remember when like bottles started changing shapes? So like your normal like bottle that you get out of a Coke machine used to look different. Why did it look different? Because no one cared about how much plastic was being used. They just cared that it looked cool. Okay, and then all of a sudden companies said, well, wait a minute, we want to try and still hold the same amount of liquid, but with the least amount of plastic possible. And then that's where calculus comes into play. Right? So you have to be at those, when you take like calculus and you take physics, that's where you're doing math and science all at once. We're just not there yet. Got a few years to go. Okay, let's look at the next one here.
Now it says a child.
See what, Drew?
Is there like graphing for this times?
Could we graph this?
Yes.
Absolutely. We could make a table and we could do negative b over 2a. And we could plug some values in. We're just not there yet.
Wow.
Okay, so a child tosses a ball upward with a starting velocity of 10 feet per second. Okay, so the last one was 47 feet per second. This one's 10. What do we think this ball is going to do?
Go faster.
Right? It's a child.
It's a bowling ball.
Okay? It's kind of what it looks like. They're throwing something that's super heavy. Okay? From a height of 3 feet. When will the ball hit the ground if we represent this motion with?
1 second.
So what is this problem asking us to do?
Solve the equation.
Solve that quadratic. How do we solve that quadratic? Quadratic formula.
Plug in.
Okay, so what does A equal?
-16.
What does B equal?
10.
What does C equal? 3. So are these really that hard of story problems?
No.
I mean, you have to read words, but you're reading words so that you can get to the equation. Okay, so we'll say -10 plus or minus 10 squared minus 4 times A times C all over 2A. Then what are we going to do?
Solve the square root.
Underneath the square root. Anyone checking me? 292?
Yeah.
Here's that number, okay. What are we then going to do with that 292?
Square root.
So we'll square root 292. It is not a perfect square.
Prime factor.
Okay, so now let's talk about this, right? Because there were times we talked about prime factoring and simplifying, and there were times we talked about using the decimal approximation. When was it appropriate to approximate, and when did we simplify and reduce, write the simpler form of that radical?
When you can't, it's a prime number, you would estimate. You don't.
Yeah, there was an appropriate time to approximate.
I mean, this is an appropriate
in like
time.
real life situations.
Okay, so I'm going to take that a step further, right? It's appropriate to approximate when we are ready for a label. We're not going to do anything else with this, right? We wouldn't say that the cost of something is $3.078. Because that's not how we talk about money. Right? We wouldn't say that a ball hits the ground at -10 plus or minus the square root of 292 all over -32 seconds. Because that's not how we talk about time. Okay, so this is an appropriate situation for a decimal approximation. Okay, so when we square root this, how many decimal points do we give?
2.
To the nearest hundredth. So this rounds to 17.09. Then what do we do? I love you all drawing the thing in the air. Right? So -10 plus 17.09 over -32. And -10 minus 17.09 over -32. And then what do we do?
So,
Right? We're going to calculate both of those. I don't know if it's, well, yeah, simplifying, I guess. -0.22.
So next is gonna be reason.
85.
it's the 0.85.
Which one are we going to use?
0.85.
We can't have,
Why are we not using the -0.22, Eric?
we can't have a negative time.
We can't have negative times, so this is our reasonable answer down here. And what label are we going to give it? Seconds. So just like we suspected, right? This had very little velocity behind it. So he, whatever the kid is, throws the ball and it goes splat. Right? Gets thrown right into the ground, basically. And even though you might say, well, that doesn't seem like a whole lot of a parabola, Mrs. McKinney.
You're wrong.
Okay, so this kid throws a ball, and it goes splat.
Yeah.
Right? Let's look at the third one. A man is standing on a high dive at his local pool, which has a height of 24 feet above the water. If he jumps up off of the high dive with a starting velocity of 6 feet per second, how long will it take for him to reach the water if we represent this motion with?
4 seconds.
What's wrong now? How is this different than what we just looked at?
The numbers aren't there.
The numbers aren't in there for us. Does that mean we just go, oh, don't know how to do this,
No.
skip, can't do it? What should we then do?
Plug in the numbers in.
Put the numbers in. We all know how to substitute, right? We plug numbers into like distance equals rate times time, area equals length times width. So we can plug numbers into this, no problem. So it says, remember that H is the height, is the ending height, T is time, and C is the starting height.
6.
Okay, so what do we know?
C equals 24.
C equals 24. Why is C equal 24?
Because he's
That's the height where he's starting at. So we know we have a plus 24. What else do we know?
The velocity, 6 feet a second.
We know that the velocity is 6 feet per second.
Are we gonna use the guess factor for this one?
That's negative 16.
Equals what? What does H equal in this one?
24.
No.
Oh, 0.
0.
Oh. Oh.
Right? We're back at the ground. I mean, thankfully there's water there so that it doesn't go splat. Right? But that's where we're reaching down here. Does that make sense? Is that something we know how to solve?
Yes.
Okay, you solve it.
Is it 16t squared?
Oh, yes. Yes, I just didn't count down the square.
I'd rather run it the other way.
What do you mean the other way?
Make the 0 on the other side.
That's fine. Just solve it.
C was 24, right?
Yep, because that's our starting height. Right? That's how high he is.
Square 6. We can approximate, right?
Why can we approximate?
We talked about
From
time.
rate.
Because we're talking about time. We're ready for a label, right? We don't talk about time as a number with a square root in it. Bailey, you need to be solving this. I know that number's right. That's what I got so far. We'll find out in a second. Oh, 3. This is where we started.
Okay, I was about to check.
Nope.
Yeah. It's 2 E's.
Which one of these answers are we going to use?
The positive one.
What label does it get?
Boom. Is this our home? No.
It's from notes.
No, like just